Let us talk about insertion at the end of a singly linked list. We are given a singly linked list and a value. Our task is to insert this value at the end of linked list. So in this linked list, we already have 10, 20, 30 and we want to insert 40. So 40 goes to the end. Let's now see this example. In this example, we are given an empty linked list and we are given a value 10. So once you insert 10, it becomes head of the linked list. Earlier, head was null. Let's now see this example. Here we have this linked list and we want to insert 20. So 20 goes to the end. So it goes after 10 and head remains 10. So the point is, if you are inserting at the end, then you will change head only when linked list is empty. In all other cases, head will remain as it is. Now please pause this video and write down a function that takes head of the given linked list as an argument, a value x to be inserted as an argument, inserts this value x at the end of linked list and returns the head of this linked list. This function should modify the head only when past head is null. Otherwise, it should return the same head. Before we talk about implementation of insert end, let's see how are we going to use it. So we have our node, standard node structure in C++ and standard node class in Java. Then we are going to write implementation of this function, right? And inside the main function, we are creating a linked list using this function. So our initially head is null. When we call insert end first time, it's going to create a new node 10 and it's going to change the head. It's going to return the head as pointer to this in C++ and reference to this node in Java. Then when we call insert end 20, it's going to insert 20 after the head. It's going to return the same head when you call insert end 20. Then when we call insert end 30, it's going to insert 30 at the end and it's going to return the same head this time also. Now please pause this video and try to complete implementation of the insert end function. Let us now talk about implementation of insert at the end. To insert an item at the end of a linked list, we need to get hold of the last node. Because if we get hold of the last node, then only we can make last next equal to the new node that we are inserting. For example, in this linked list, if I want to insert 40, I'll first allocate memory for 40. That's what we have done as a first line in both the codes, right? We allocate memory for the new node. Say access 40 and this is our current list. We'll allocate memory for 40. Now what we want is, we want this 30s next to become 40. This is what we want, right? 30s next to become 40. How do we make 30s next 40? For that purpose, we need to get hold of 30. We either need to have pointer to this 30 in C++ or we need to have reference to this node 30 in Java. How do I get reference to this node 30? What we do is, we run a loop that begins from this head and it stops when it finds a node whose next is null. Because when you are given this linked list and this is the last node, its next must be null, right? So we run a loop, current equal to head, current.next is not null, current equal to current.next. Similar code we have in C++. See, if I change this condition to current not equal to null, then what will happen? After you come out of the loop, your current will be null. You want current to point to the last node or refer to the last node. That's why we run this loop this way. Now, one corner case that we must handle explicitly is when our linked list is empty. That's what we have handled here. After allocating memory, we check if head is null, then we return this allocated node explicitly. The reason is, if your head is empty, then you should not access head's data, head's next or anything. But what will happen if I don't handle this condition explicitly? We'll begin with current equal to null, then we'll say null.next or null arrow next not equal to null, run this loop. And you are accessing null something, which will cause segmentation fault in C++ and null pointer exception in Java. So to ensure that we do not get that problem, we have explicitly added null case in the beginning. If head is null, then return time. Also, this is the only case that changes head of the linked list. In the other cases, we simply return the same head. Right? In this particular case, we return newly allocated node as head of the linked list and we use it in the main function. So the idea of insert end is simple. We first allocate memory for a new node. then we find the last node of the linked list, then we make next of the last node as new node.